Hello and welcome to EduPorm EdTech. You're watching Expert Chemistry Lectures with Abhinav Gaur. Today in this lecture, we will study about solid state chemistry and we will start by understanding the classification of the solids. So the solids are classified into two broad categories. The first category is crystalline solid and the second broad category is the amorphous solids. Now these crystalline solids are further classified based on the forces that keep the particles together. The first category is the molecular crystalline solids. The second category is the ionic crystalline solids. The third category is the metallic crystalline solids, and the fourth category is the network or covalent crystalline solid. So in this lecture we will study the crystalline solids and the amorphous solid, and at the end we will compare both crystalline and amorphous solid. So let us start by understanding what are crystalline solids. So students, this is the structure for the crystalline solids. So the first point for the crystalline solids is that they have uniform arrangement of particles. That means the particles are arranged in order and this order is repeated for a long range. So the order is called as the long range order. Okay, so you can see in this photograph, in this figure, that all the atoms, molecules and ions are arranged in a proper order, as well as you can see the repetition of this system in all the possible direction towards a long range. Okay, this repetition is towards this side, will be towards this side, will be towards this side, will be towards this side. So they have uniform arrangement of particles and the arrangement is repeated for a long range. So we say that they have long range order. Other than this, when we cut them, when we cut the crystalline solid, we get two different surfaces which are smooth. So whenever we cut a crystalline solid, it gets divided into two parts with smooth surfaces. They have sharp melting point. They have sharp melting point. That means if, for example, this is A and this is our solid, and I'm saying this solid A melts at 1101 degrees Celsius. So this will melt exactly at 1101 degrees Celsius, not at 1103 degrees Celsius and not at 1100 degrees Celsius. But it will melt at a sharp point which is the 1101 degrees Celsius. So they have sharp melting point. All these properties are the basic properties with the example of quartz. I'm taking the example of QUARTZ, quartz. Okay, quartz is an example of crystalline solid. Other than quartz, the example is diamond. Diamond is also a crystalline solid. Okay, so they have uniform arrangement of particles, they have long range order. Whenever we cut them, we get two different parts having smooth surfaces. They have sharp melting point. Now the most important property that they show is anisotropy. They are anisotropic in nature. So students, keep this term in your mind. Later I will explain what is the meaning of anisotropic. Okay, so this is all about crystalline solid. We will learn some more points when we study the difference. For now, let's move to the amorphous solids. So students, as you can see, this is the arrangement of particles in case of the amorphous solids. So you can see that in this case, this arrangement is irregular, or we can say this arrangement is non-uniform. So the first point is that in case of amorphous solid, the arrangement of particles is non-uniform. As well as you can see that the space present in this system and the space present in this system is different. That means there is no repetition, or we can say they don't have order, or even if they have order, the order is of short range. So they have short range order. As well as if we cut the amorphous solids into two different parts, then we will get two different parts having irregular surfaces. Their surfaces will not be smooth. The next point, they have a range of melting point. That means at a particular temperature, they first get soft and then they start to melt. For example, I have a solid A. Now this solid A at 65 degrees Celsius get soft, while at 70 degrees Celsius it starts to melt. So it has a range of melting point between 65 to 70 degrees Celsius. So all the amorphous solids have the range of melting point. Okay, so far we studied that they have non-uniform arrangement of particles, short range order. When we cut them, we get two parts having irregular surface. They have range of melting point. Now they show isotropy. Okay, they are isotropic in nature. So now we will finally understand what is the meaning of isotropic and what is the meaning of this anisotropic. Okay, so what you need to remember is, first of all, that crystalline solids are anisotropic while the amorphous solids are isotropic. Okay, so what is anisotropy and what is isotropy? So I will start with isotropy. Okay, I will start with isotropy. So what are these isotropic substances? For example, this is our solid system, and in this solid system I am standing at this point. If I am going towards this side, the value of physical properties such as refractive index or resistance is found, let's say 5 ohm. The resistance is found to be 5 ohm. Now I am going to this direction. In this direction also the value of refractive index and resistance are found same. The value of resistance, let's say here also it is 5 ohm. Similarly, in this direction the value of resistance and refractive index is same. In this direction it is also same. So the meaning of isotropic is that physical properties such as the refractive index and resistance remain same in all the direction within the crystal. Okay, so in case of anisotropic solids, amorphous solids, we say, I'm repeating again, in case of amorphous solid, we say that the physical property remains same in all the directions. Whereas, what is an isotropy? Now we will understand anisotropic nature and the anisotropic substances. So, in case of anisotropic substances, the physical properties such as resistance and refractive index is different in different direction. For example, here the value of R, resistance is 5 ohm, and here the value of R, that means resistance, is 6 ohm. So the physical properties such as refractive index and resistance is different in different direction in case of crystalline solids. Now you may be thinking that in case of crystalline solid the arrangement was uniform, then why there is difference in property. Whereas in case of amorphous solid, the arrangement was non-uniform, still why they have same property. Okay, so I will explain this in another video and mention the link of that video in the comments. Okay, so please go check the description as well as in the comments. So check the description as well as comments to understand why this property is shown. Now let's study the difference between crystalline and amorphous solid. So let us understand the difference between crystalline solid and amorphous solid. First of all, as I already discussed, that crystalline solids have definite characteristic geometrical shape, whereas the amorphous solids have irregular shape. The crystalline solids melt at sharp and characteristic temperature, whereas the amorphous solids gradually soft over a range of temperature. When we cut the crystalline solid, we get two pieces having smooth surfaces, whereas when we cut the amorphous solids, we get two pieces with irregular surfaces. They have definite and characteristic heat of fusion, whereas they do not have definite heat of fusion. They are anisotropic in nature, while these are isotropic in nature. These are called as true solids, whereas they are called as pseudo solids or supercooled solids. In the next lecture, we will understand why they are called as pseudo solids and why they are called as supercooled solids. They have long range order while these have short range order. So this is all about crystalline solid and amorphous solid. Please go check the next video of this series to understand why the amorphous solids are called as pseudo solids and why they are called as supercooled solids. Thank you.